In this lesson, we will learn about inverse kinematics. In the last lesson, we learned one way to animate bones, forward kinematics, or in other words, animating down the hierarchy. FK has a few problems that inverse kinematics helps us solve. Let's take a look at an example, a hand holding a pole. We want our character to extend his body out from the pole, but still hold on to the pole. It would be very difficult to animate this using FK, because every time we change the bones above the hand, the position of the hand would change. And we can easily animate this using inverse kinematics, or IK. To use IK, we need to create an IK solver, which computes how to rotate the bones between the shoulder and the hand. Now we can move our body anywhere, and the hand will stay in the same place. Inverse kinematics creates a relationship between two or more bones, controlling their rotation. When you make an inverse kinematic system, you also create an effector at the location of the last bone in the IK system. The program then calculates how to rotate the bones to follow the effector. Now, using IK, we can animate up the hierarchy. Let's take another look at our IK controlled arm. We can move the rest of the body around fine, but something is wrong with our elbow. It is just moving around randomly. This is because the IK solver has a reference plane, also called the plane of resolution. This defines how it will twist. Because we are only controlling 2 points, the shoulder and the wrist, the reference plane is calculated by the computer. With 2 points, the computer can only draw a line, so the elbow rotates around that line, pretty much making an infinite amount of possibilities. We can fix this by adding a third point to our IK system, a pole vector constraint. Now, this pole vector locks the reference plane to a control object. Since the elbow is restricted to a third point, we have complete control over our arm, because with these 3 points, we now have a plane. However, inverse kinematics isn't a perfect system. It does have a few issues. One problem IK has is snapping. If you move the effector further than the bone chain can reach, it straightens out to the point where it locks. Now, bringing the effector back in range will cause the IK system to snap. This is a common issue when animating with IK. Another downside of IK is it takes more animating to get a nice arcing movement. Using FK, we can get a really smooth movement using just 2 keyframes. Now, most skeletal animations is done with a mixture of FK and IK, because each is useful in different situations.